In this lecture, we want to explore the third step of the machine learning process, which is model training. Training a model involves feeding the data to a model and iteratively adjusting the parameters of the model to maximize the performance on a given task. The aim of this process is to minimize the difference or loss between the predicted value and the actual value. For example, if the actual value of one data point is 100, but the model after it is trained predicts the value as 90, then you have a loss of 10. If this loss or 10 is acceptable based on your use case, then the stopping criteria is met. Otherwise, we will adjust the parameters and we run the data through the model again, and then we keep doing it until the loss is acceptable. As we said, model training is iterative, so we keep looping the model through these two steps. We run the model on an input and we obtain the output. We adjust the model based on the evaluation of the output until the output is satisfactory. Now let's have a look at model training in supervised learning. We repeat these steps, these 4 steps in supervised learning. We draw a batch of training samples, which is X, and its corresponding target value, which is Y. In supervised learning, Y is either 0 or 1. Then we run the model on X to obtain the prediction of Y. So we call that Y cap or Y hat of X. Then we compute the loss of the batch, a measure of the difference between the Y cap and Y. Then we update all the weights of the network or the batch in a way that it slightly reduces the loss on this batch. So if we explain these 4 processes on the image that you see on the right side of the screen, we have a database of training data, and each data point is called X. Our model is a mathematical function called f that accepts X, but also it has a parameter that we call weight, and we show normally those parameters as theta, and they are theta 0 to theta n. When you see a theta without an index, it means that it's a vector of all the parameters. So our model is a function of f that accepts one data point, which is x, and a weight that we can change called theta, and then it gives us an output, which is the y cap. So the y cap is the predicted value and y is the actual value. So we can read this like this. X is the training sample, Y is the target that is associated with X, Y cap is the predictions, theta is the parameters or weight of the model, and these are the one that we tweak in every iteration to minimize the loss. The loss function is normally showed as J of theta. We will look at the loss function later. So this function is used to calculate the loss or difference, and based on that we decide how we tweak the parameters or thetas to minimize the loss. Let's have an example and see that how machine learning is similar to human learning. So we want to see that how a person learns playing an instrument and how that translates to machine learning. In the second column from left, we have the process of learning a musical instrument by a person. So a person like you chooses the notes for a set of a music piece. Those notes are X. The recording of that piece is the target, which is Y. Then you, which you represent the model, practice these pieces of music to achieve a similar performance to the recording that you hear. So your output when you play a cello or piano, for example, is Y cap, but when Beethoven played the piano, that would be like Y. So that is your target. Then compare what you produce, Y cap, with the exemplar, which is Y, and identify mistakes or areas where you need to improve. So that is basically calculating the loss. Then you adjust the technique in order to avoid making mistakes and improve the performance. That is equivalent of adjusting the parameters or thetas. Now see how this resembles to machine learning. In machine learning, we draw a batch of training samples, which is the notes, and its corresponding targets, which is the playing of that note. Then we run the model on X to obtain predictions. For example, say a computer would try to play that note. Then compute the loss of the network on the batch, a measure of the difference between Y cap and Y. Then we update all the weights of the network in a way that slightly reduces the loss on this batch. If the loss is acceptable, we stop. Otherwise, we repeat these 4 steps again.